Hi everyone, this is just a quick catch up in case you missed anything or if you were absent for today's lesson. So in today's lesson, we're talking about atomic structure. So if you look on Schoology, we're going to be working in the, in the Unit 2 folder. And the folder that we're going to be working on today is called Lesson 2. So Unit 2, Lesson 2, and it's called Atomic Structure. So if you could start by opening up the guided notes for that, that should be the very first link way at the top. What we're going to do today is we're going to talk about the structure of the atom. So here's just a picture of what an atom looks like. We saw that same picture back on Monday when we were talking about the history of the atom. But today what we're going to talk about is the subatomic particles that make up an atom. So let's start off by looking at this sentence here. It says atoms are the building blocks of elements. Elements is this word right here. So basically what that means is atoms come together and they form, a whole bunch of one type of atom forms an element. So if I have gold and gold and gold and gold atoms and I put them all together, I'll have the element gold, like a piece of gold, like on a ring. Second part. All atoms are made of different arrangements of 3 subatomic, so that means smaller than the atom, subatomic particles. So those particles are the ones that are down here, the protons, neutrons, and electrons. And we learned about protons, neutrons, and electrons on Monday when we talked about the discovery of, or Tuesday, depending on your class, when we talked about how the atom was discovered and how all of these different pieces came together. Okay, let's take a look at the second page. So going into the structure of the atom, we're going to start off, oops, wrong way. We're going to start off by talking about protons, then we're going to talk about neutrons, and then finally we'll talk about electrons. So we're going to start off talking about protons. So first of all, you'll notice over here that we're going to use this red circle to represent a proton. And it's fairly big, especially when you notice, when you compare it to the size of an electron. A proton is really big. So protons have a charge of +1. They have a mass that is equal to 1 AMU. So AMU is like a unit, just like grams was a unit, and milliliters was a unit, and liters was a unit, all of that from unit 1. The unit for the mass of an atom is called AMU, and it stands for atomic mass units. So atomic mass units. Okay, protons, again, this right here, they are located in the nucleus. That's the center part of the atom, and they are used to identify an element. We are going to decide what element we have by looking at the number of protons. So the number of protons determines what element you have. Okay, our second piece, our second particle, as you can see behind me, is the neutron. It's about the same size as a proton. So if you look over here, it's roughly the same size as a proton. It has a charge that is neutral. That means no charge whatsoever. So it's not positive and it's not negative. So the charge is neutral. The mass is also 1 AMU, the same mass that we had for a proton. So both of them have a mass of 1 AMU. It is also located in the nucleus, just like a proton is. And it is used to determine the isotope. Now, this is a word that we're going to talk a lot about on Friday. So we're not going to talk about it today, but we'll talk about the word isotope on Friday. Next one. Our third particle, as you can see behind me, is called the electron. Notice that it is much smaller than a proton or a neutron. Protons and neutrons were really big. Electrons are very, very small in comparison. So their charge is -1. Their mass is very small. And I use this term here. It's called negligible. That means it's so small that you can forget about it. You can ignore the mass of an electron because it's so small compared to the mass of a proton or a neutron. It is located outside of the nucleus. So we learned about energy levels on Monday when we talked about the Bohr model where we had the electrons on the outside. So outside of the nucleus, and it is used to determine charge. And again, charge is something that we're going to talk about in our next lesson. So we're going to talk about isotopes in our next lesson, and we're going to talk about ions in our next lesson, but not for today. So putting all of those pieces together, we get something like this. This is our atom. So in the center, which we call the nucleus, we have both protons, which are these red circles, and we have neutrons, which are the green circles. And then outside of the nucleus, so all the way around here, we have our electrons, and those are these guys. So these that are the yellow are the electrons. So now we're going to talk about a couple of pieces here. So the first one that we're going to talk about is the atomic number. Now, before I go and talk about atomic number, I'm going to mention to you that I have put a periodic table that looks like this into your folder. So if you could actually go to the folder and open up that periodic table, we could take a look at it together. So if I open up my periodic table, so I'm just going to share my screen here with you. So this is what the periodic table will look like, and it has a couple of different pieces to it. The very top number is called the atomic number. So we're going to talk about the atomic number. All right, so first, the atomic number is equal to the number of protons. That particle that we just talked about, that red circle that we had over here, those were protons, and the atomic number is equal to the number of protons. Second one, that atomic number is different for each element. So the atomic number is different for each element, just like it has a different name, it has a different number. The third one, as I just pointed out to you, that number is on the top of the element symbol, and I'll show you that again in a second. And then finally, for what we are doing today, the number of protons is equal to the number of electrons, so the atomic number will also be equal to the number of electrons as long as we have a neutral atom, so an atom that is not positive nor negative. So here is a picture of a periodic table. The periodic table that I gave you has 3 parts to it. So I'm going to make this really big. So let's take a look. So the top part is called the atomic number. And remember, the atomic number is equal to the number of protons. The middle part is called the symbol. And then the bottom part here, that's where the name is. So this element, C, it has a name of carbon. So what I'm going to ask you to do is let's look at some atomic numbers together. So let's first look at Na. So on your periodic table, find the element Na. It's located over here on the left side. Oops. And we're going to write down its atomic number, which is, keep doing that, which is 11. So the atomic number for Na is 11. For the next one, Hg. So Hg is kind of in the middle of the table over here. If you look up, the atomic number for Hg is 80. Next one that you had is nitrogen. This time I gave you the word. So you have to find the word nitrogen. That's up here in the top right corner. So nitrogen has the atomic number of 7. And then finally, the last example that we're going to look at, silver. Silver is kind of in the middle of the table. Silver has the atomic number of 47. Oops. So sodium is 11, mercury is 80, nitrogen is 7, and silver is 47. All right, the next piece that we're going to go through. what is the element name? This time I'm going to give you the number, the atomic number, and I want you to look up the element name. So we're looking at the numbers that are on top. So the element name for 30 is zinc. Then for 54, so look for 54 on your periodic table. The element name, it's all the way over here on the right side. The element name for this is xenon. That's kind of cool. The next one is number 78. You've probably heard of this one. That is the element platinum. And then finally, our last example is for the element number 24. So 24 is the element chromium. So again, that's just looking on the periodic table, looking for the atomic number, and finding what its name is. So let's go on and talk about the next piece, which is the mass number. So I wrote up here, what is the mass number? So the mass number is equal to, or the mass number is the total number of protons. That's what goes on that line, protons and neutrons in the nucleus of an atom. And what you're going to do here is you're going to simply add these two pieces together. So if you notice, if I have 20 protons and I have 20 neutrons and I add them together, I'll get an atomic mass number of 40 AMU. So the protons and the neutrons get added together to give you that mass number. So protons and neutrons. Alrighty, so now we're going to put all of these pieces together. And we're going to look at two examples. So the first example is for copper. So using your periodic table, find where the element copper is. I'll give you a little hint. It has the symbol Cu. So looking at the periodic table, its atomic number is number 29. Remember that these two things are equal to each other. So the number of protons is also going to be 29. The next part is these two are equal to each other. They are equal to each other if we have a neutral atom. So today, we can say that these two numbers are also the same. So that's 29. And then remember, to get the mass number, we have to add together protons and neutrons. So to get this one, the mass number down here, we're going to take this number, 29 here. That's the number of protons. And we're going to add it to the number of neutrons. And we're going to get a mass number of 64 AMU. So that's our first example, which was copper. Okay, let's take a look at our second example. So our second example is going to be the element fluorine. So if you're looking on your periodic table, fluorine is represented by the letter F. So it's up here in the top corner. So it is atomic number 9. Remember that these two are equal. So the number of protons will be 9. And if we're talking about a neutral atom, which we are today, this number is also going to be 9. Now, to get the last piece, to get this mass number, which is equal to 19, we had to add together two numbers. So we add together protons and neutrons. In this example, they didn't tell you what the number of neutrons was, but they did tell you the total mass. So what plus 9 plus whatever this is, equals 19. So this must be equal to 10. So the number of protons plus the number of neutrons equals that mass number. So it was 19 in this case, so that meant the missing number here was 10. So if you were in class, you saw what we did next was we went and looked at the element inventory assignment. So this assignment is found on Schoology. You're going to have to submit this. It's going to be like a homework assignment. But I'm going to go through the first couple of them together with you, and then after that you can go from that point on your own. So first of all, they might give you a different piece of information. So sometimes we're going to be working from left to right. Sometimes we're going to be working right to left. We'll move around. Keep in mind, this column right here, this column, and this one will all have the same number. So the atomic number, the number of protons, and the number of electrons will be equal to each other. So for the element silver, I'm going to go to my periodic table. I'm going to find where silver is on the periodic table. And we find out that it is number 47. So silver is element number 47. Once you know this number, you can put that in all three spaces. The symbol for silver is Ag. And then finally, to get the number of neutrons, remember that these two pieces, so this plus whatever this is, add together to give you that 108. So 47 plus a number has to equal 108. So what number would go here? So hopefully you're going to say number 61. Okay, let's take a look at our second example. In the second example, they did not give you the name. So instead, they gave you the atomic number. So just like we practiced before, you're going to go to your periodic table. You're going to look for atomic number 20. You're going to find out that atomic number 20 is the element calcium. The element symbol is going to be Ca. And now, this number, wherever these stars are, this number is 20, this number is 20, this number is 20. Now, to find the mass number, see how I made this green? You add together these two green pieces. So this one plus this one equals that one. So 20 plus 20, we put 40 over there under the mass number. Okay, for our next example, we're not given the name, we're not given the symbol, we're not given the atomic number, but we are given the number of protons. So protons and atomic number are equal to each other. So these are both 30. The number of electrons will also be 30. So you can go to your periodic table, you can look up what has an atomic number of 30. So we'll find out that our 30 is for zinc. So it has the symbol Zn. And the number of neutrons, we're going to do it the same way we did it up here. The number of neutrons is going to be equal to 30 plus whatever this is, has to equal 65. So this number is going to be 35. Okay, the next example we have is neon. So neon, its symbol is Ne. You will find it on the periodic table on the right side, kind of near the top. It has an atomic number of 10. So once we know this column, we can fill in 10 protons, 10 electrons. And now, keep in mind, 10 plus what equals 20? This must be another 10 here. Okay, the next one is difficult because they don't give you the name, they don't give you the atomic number. In fact, this column, this one, and this one, they're all blank. So how do we figure out what element we have? Okay, well, you're going to use this piece of information. What plus 12 equals 24? So that number turns out to be 12. Once we know this column, we also know this one. So this one will also be 12. This one will also be 12. And then we can go to our periodic table. We'll find the element 12. So in this case, that is the element magnesium. And the symbol for magnesium is Mg. Okay, the next one. The next element we have is Au. So this time we have to start with our periodic table and find where Au is. So Au is gold. So over here I'm going to write gold. If you look on the periodic table, gold has the element, or the atomic number rather, of 79. So that 79 that's here, that's going to go here. It's also going to go here. These two pieces get added together, 79 plus 118. We wind up with a total of 197. That is our mass number. For the next example, we start by looking for this atomic number. The atomic number is 7. That means we have nitrogen. The element symbol for nitrogen is N. 7, if we have 7 as the atomic number, it is also our number of protons, number of electrons. And then finally, what plus 7 plus whatever number this is equals 14. So that must also be the number 7. And then we're going to do one more problem together. So this last problem here, we have iron. We look on our periodic table to find out that iron has the atomic number of 26. So I can write 26 here, I can write 26 here. The symbol for iron is Fe. And then when I add these two together, 26 plus 30, I get 56. So 56 is my total. Okay, at this point, I'm going to ask you to finish the remaining part of this assignment on your own. Please make sure to hit submit so that I can grade the assignment and give you credit for it. And I'll see everyone in our next class. Thanks, everyone. Bye-bye.